Good morning everyone, my name is Silvy Tjan and I am from SMA 1 IPA A. Today I will be discussing about ion. Types of ions. According to the charges, there are two types of ion. The first one is a cation, which refers to a positively charged ion. The second is an anion, which refers to a negatively charged ion. And according to the number of atoms, there are two types of ions also. The first one is the monoatomic ion, which is an ion consisting of only a single atom. The second is the polyatomic ion, which is an ion consisting of two or more atoms. Examples. The first one, we have the ammonium ion. Ammonium ion consists of two atoms. The first one is a nitrogen and the second one is a hydrogen. So this makes ammonium a polyatomic ion. And let's take a look at the charges. Ammonium has the charges of 4+, which is a positively charged ion. So ammonium ion is a polyatomic cation. Next, we have the phosphide ion. The chemical formula is phosphorus 3-, which means phosphide ion is a monoatomic ion. And phosphide has the charges of -3. So phosphide ion is a monoatomic ion. Next, we have the Lewis dot symbol. Lewis dot symbol is a symbol of an element with one or more dots representing the valence electron of the elements. We have some examples here. The first one is the calcium with the atomic number of 20. We'll first write down the electron configuration of calcium. The electron configuration of a calcium is 2, 8, 8, 2. And we can see that calcium has a valence electron of 2. So we will write down Ve equals to 2. After determining the valence electron, we will now draw the Lewis dot symbol. First, we write down the atomic symbol. Next, we will use the dot. Because calcium has a valence electron of 2, so we will draw 2 dots. 1 and 2. So this is now the Lewis dot symbol of calcium. Next, we have selenium. Selenium is an atom with the atomic number of 34. As usual, we will first write down the electron configuration. The electron configuration of selenium are 2, 8, 18, and 6. And now we know that the valence electron of selenium is 6. Next, we will draw the Lewis dot symbol for selenium. We will write down first the atomic symbol. Next, we will draw the dots. We will draw 6 dots because selenium has the valence electron of 6. 1, 2, 3, 4. And we will go back to the first place. 5 and 6. So this is the Lewis dot symbol for selenium. Now, how can an element be stable? The answer is an element can be stable when they share their electron with the other atom. And there is now also an octet rule which state for atoms to be stable, they need to achieve the valence electron of noble gas, which is equal to 8. Now this means that calcium needs to give away 2 in order to be stable, while selenium needs to take 2 more electrons in order to become stable. Next, let us proceed to the ionic equation. Ionic equation is an expression of the formation of ion by gaining or losing a certain number of electrons. Now, how do we express the ionic equation? We have some example here. The first one is the sulfur with the atomic number of 16. We will now write down the electron configuration first. The electron configuration for sulfur is 2, 8, and 6, which means that sulfur has the valence electron of 6. After we had the valence electron, we will now write down the ionic equation. The first step to write the ionic equation is to draw the Lewis dot symbol first. We write down S and we place 6 dots. 1, 2, 3, 4, 5, and 6. Next, we write down plus 2 electron. Okay, why plus 2 electron? Because the valence electron of sulfur is 6, which means that sulfur needs to take in 2 more electrons in order to become stable. So we need to write down plus 2 electrons. And we will draw an arrow. And we will write down the ionic equation. S plus the 2 electron become 2 minus. So this is now the ionic equation of the formation of sulfur by following the octet rule. Next, we have aluminum. First, we will also write down the electron configuration for aluminum, which is 2, 8, 3, which makes aluminum has the valence electron of 3. Now we will write the ionic equation for the formation of aluminum. We will draw first the Lewis dot symbol for aluminum, Al, add dots, add 3 dots, 1, 2, and 3. Now, aluminum has the valence electron of 3, which means in order to become stable, aluminum needs to give out 3 electrons. So, this makes aluminum minus 3 electron. But in order to write down the ionic equation, we must never use minus, which means we will have to transfer the negative 3 into the right side. So this will now become Al 3 plus. This transfer to the right side will become plus. Now this will become the ionic equation of aluminum. Next, we have the chemical bonding. Chemical bonding happens when two or more atoms join together in order to become stable, forming a molecule. There are two types of chemical bonding. The first one is the ionic bond, which happens between the metallic and non-metallic ions. The second is the covalent bond, which happens between the non-metals. Example, we have number 1, CO3. Now, how do we determine this is an ionic or covalent bond? Now, carbon is a non-metallic atom, and oxygen is also a non-metallic atom, which means a non-metallic and non-metallic will form a covalent bond. So CO3 is a covalent bond. Magnesium is a metallic one, and the nitrogen is a non-metallic, which makes magnesium nitride an ionic bond. Another example is ammonia or NH3. Nitrogen is a non-metallic and hydrogen is also a non-metallic, which makes ammonia a covalent bond. Next, I will be discussing about the lowest dot structure for ionic compound. Now, example, we have lithium and bromine. We'll first write down each atom's electron configuration. We'll start from lithium. Lithium has an atomic number of 3, so the electron configuration for lithium is 2 and 1, which makes valence electron of lithium is 1. Now for bromine, which makes the electron configuration 2, 8, 18, and 7. And now we have the valence electron for bromine is 7. After we got the valence electron, we can now draw the lowest dot structure for each atoms. We will first start with lithium. This time I will be using a cross instead of a dot to represent the lowest dot structure for lithium. Lithium has a valence electron of 1, so there is only one cross for lithium. Next, we have bromine, Br. I will use dots to represent bromine. Bromine have valence electron of 7. So 1, 2, 3, 4, 5, 6, and 7. Now we will combine the both of them. How to combine? In this structure, lithium with the valence electron of 1 will give bromine in order to become stable, while bromine will take the 1 electron from lithium in order to become stable, which now means the received one will place it in the brackets. We'll write lithium here and we'll place here bromine. And we will add the brackets. So this is the lowest structure for lithium and bromine. Next, we have sodium and oxygen. Sodium has the atomic number of 11, which makes the electron configuration 2, 8, and 1. So sodium has a valence electron of 1, while oxygen has the atomic number of 8, which makes the electron configuration 2 and 6. So oxygen has a valence electron of 6. Now we will draw the Lewis dot structure for each atom. We'll write down Na, NO. Sodium has a valence electron of 1, so I will put one X here. And oxygen has the valence electron of 6. So we will draw 6 dots. 2, 3, 4, 5, 6. Now, sodium needs to give out 1 in order to become stable, while oxygen needs 2 more electrons in order to become stable. But in this condition, there is only 1 sodium. So now we will do a crisscross. NaNO. Sodium and oxygen. Sodium needs to give out 1 electron, which makes sodium plus 1, while oxygen needs to receive 2 more. So oxygen is minus 2. So this will become Na2O1, but we doesn't need to write the 1. Now, after we use the crisscross method, we will now know that there must be 2 sodium. So, how do we draw the Lewis dot structure for sodium and oxygen? We will now write 2 sodium. Since oxygen is the one who is receiving the electron, we will put oxygen in the brackets. We will draw the dots first. So there will be 2 sodium, which means there will be 2 cross for each. So this is how we represent the Lewis dot structure for sodium and oxygen. We can also express the Lewis dot structure in another way. Example. In here, because sodium gives the oxygen 1 electron, which this will make sodium plus 1. Now the oxygen is receiving 2 electrons, which means there will be negative 2. So this is another way of expressing the Lewis dot structure for ionic compound. Next, for lithium and bromine, since lithium is giving away 1 of its electrons, so this will mean that lithium is plus 1, while bromine is negative 1 because it will be receiving 1 electron from lithium. And because this is 1, we don't need to write down 1, just negative and a positive sign. So this will now be all the lectures in this video. Thank you.